The gap between two of the world's greatest continents, Europe and Africa, is just
14 kilometers. It's so close that you can clearly see one side from the other. But have you
Look at a map of the world, and you will find places where entirely different continents practically touch. The most tantalizing of these is right here, across the Strait of Gibraltar. At its narrowest point, the physical gap separating Spain from Morocco is exactly 14 kilometers. You could drive that distance in under 30 minutes. Humanity has already solved far greater distances. In the 1990s, construction crews completed the 50-kilometer rail line directly underneath the English Channel. Yet this specific stretch of water remains empty, despite its staggering economic gravity. Every single year, 33% of global oil and gas and 80% of the European Union's merchandise trade pass through this narrow choke point. A fixed link here would cut transit times between major hubs like Casablanca and Madrid from 12 hours to just 5.5, providing a high-speed rail alternative to the shipping lanes that currently carry the majority of the continent's electronics and raw materials. Engineers have obsessed over this exact crossing for a century. The desperation to link the continents peaked in the 1920s with a series of radical proposals. German architect Hermann Sorgel pitched a project he called Atlantropa. His strategy was to physically alter the ocean itself to fuse the two land masses together. Sorgel wanted to construct a massive hydroelectric dam across the strait to partially drain the Mediterranean Sea. To keep shipping lanes open, he designed massive lock chambers, allowing cargo ships to step down into an artificially lowered Mediterranean. The environmental risk and financial cost of draining an entire sea meant Sorgel's project died with him in 1952. His failure indicated that conquering the strait requires working with the existing geography rather than trying to delete it. Decades later, modern engineers focused their surveys on the most mathematically obvious path, the straight 14-kilometer line known as the Canyon Route. To cross it, an American architect named Eugene Sui designed a massive floating bridge, intending to avoid the deep water by anchoring the structure to the surface rather than planting pillars in the ocean floor. But the strait possesses a unique physical profile. This animated map illustrates the first major trap: competing currents. Cold, dense water from the Atlantic pours in from the west, while warm, lighter water from the Mediterranean pushes out from the east. When they collide, they create vertical vortices and surface currents that reach 11 kilometers per hour. Even if a design can handle the swirling water, the canyon route hides an abyssal drop. The seafloor plunges down 800 meters. For a traditional bridge, you would have to construct support pillars 3 times the height of the Eiffel Tower just to reach the surface. And the geology at the bottom is unstable. The seabed here is packed with breccia and clay. It is highly porous, acting like soft mud filled with loose stones. Any heavy structural pillar would cause the ground to shift and crumble. Worse, this entire stretch sits directly above an active tectonic fault line between the Eurasian and African plates. This historical illustration shows the aftermath of the Lisbon earthquake, a reminder of the seismic tremors that regularly fracture this specific zone. Finally, building earthquake-proof pillars in 800-meter deep water is only half the challenge. The bridge deck must sit at least 70 meters above the surface to allow the world's largest oil tankers to pass through the strait. These physical constraints make the shortest, straightest line an engineering impossibility. In 2005, a joint Spanish-Moroccan committee shifted their strategy and abandoned the 14-kilometer path entirely. They looked further west, mapping out a new, curved path called the Threshold Route. It doubles the crossing distance to 28 kilometers. This longer route offers a massive geological advantage. Here, the ocean is only 300 meters deep, and crucially, the seabed sits on a foundation of solid, drillable rock. Because this rock can support the weight of heavy machinery, the committee transitioned from bridge concepts to a design featuring 3 parallel railway tunnels bored deep beneath the seafloor. By prioritizing geological stability over the shortest distance, engineers finally produced a mathematically viable blueprint to link the continents by 2006. The project moved into its final stages. A Swiss engineering firm named Lombardi won the official contract, and construction was slated to begin by 2008. Then, the project stalled. The drill bits never touched the rock. The final barrier was not found in the water, but in a series of diplomatic disputes. The friction centers on Ceuta and Melilla. As this weathered welcome sign indicates, these are Spanish-controlled territories located entirely on the North African coastline, sharing a direct land border with Morocco. This aerial view of Melilla's harbor shows the scale of these Spanish enclaves. They sit right at the opening of the proposed tunnel route, a remnant of history that Morocco has disputed for decades. Just as the tunnel project prepared to break ground in 2008, the Spanish king made a high-profile visit to these enclaves. In retaliation, Morocco withdrew its ambassador from Spain, halting all joint operations. This pattern repeats. In 2020, Spain allowed a Western Saharan rebel leader into their country for medical treatment. Morocco protested the decision, and once again, diplomatic momentum collapsed. The decades spent mapping the ocean floor and calculating currents were instantly nullified by a breakdown in political communication. Today, modern engineering possesses the brute power to defeat deep ocean trenches, violent currents, and solid subterranean rock. Yet all that heavy machinery remains idle because we have not found a way past historical mistrust. The math is solved and the blueprints are ready. But until Spain and Morocco can build a foundation of political trust, that 14-kilometer gap between Europe and Africa